Hello, my name is Tomas Krasensky. Let's talk about metal cutting. I don't mean dividing into ferrous and non-ferrous, light and colored metals, but cutting in the sense of breaking a piece or whole into individual parts. Every job with metal material, whether it's solid profiles or sheets, starts with cutting them into the required dimensions, and this can be done in many different ways. Besides cutting, there's also shearing, grinding, or melting. Theory is great, but green is the tree of life, they say, so let's get straight to the practical demonstrations. For example, a regular metal saw, which we simply call a hacksaw. For a DIYer who doesn't worry about work efficiency, it's a good helper for many cases, especially for cutting metal profiles. The machine equivalent of a hand metal saw is electric saws, whether band saws or jigsaws with the appropriate blade for metal. Electric saws save us effort and allow for more precise work, especially when it comes to band saws. Cutting is essentially chip machining, meaning that using a tool with a high hardness spindle, we gradually literally shave off small chips from the workpiece. The advantage is that a quality tool doesn't wear out so quickly that it disappears before your eyes. It just dulls over time and it needs to be sharpened. With a faster process, heat is generated. However, both the tool and the cutting area can be easily cooled. Most of the time, it's enough not to push down on the saw and to use cutting oil, which reduces friction that causes binding and simultaneously dissipates heat from the heated metal better than air. Another method of cutting metal is grinding. We might use an angle grinder with a so-called cutting disc more often than a metal saw. The reason is the speed of work. And with battery-powered grinders, there's also great operability, flexibility, and immediate readiness to work. But there's a catch. Since it's an abrasive machining process, a lot of heat is generated. Grinding with removal and cooling is accompanied by high friction, which puts a lot of thermal stress on the workpiece. The evidence is a shower of sparks flying from the diminishing tool and the thermal mat on the workpiece. This is unacceptable in some cases, whether for safety reasons due to fire regulations or because of undesirable changes in the mechanical properties of the material, usually a reduction in hardness. An interesting alternative to grinding is cutting metal using a special saw blade. They are available for both stationary saws, which resemble miter and chop saws for wood, and for handheld saws. The blades are made of high-quality sintered carbides and are specially sharpened. Characteristic of metal cutting blades is the high number of teeth, which are low and have a robust back that withstands higher stress on the teeth during cutting. Unlike grinding, this is a chip removal process, so it doesn't generate as much heat, thus avoiding unwanted heating of the workpiece. The cut is also cleaner without large burrs, and the work speed is higher. And thirdly, we can shear metals. In common cases, this method is used for sheets, but in industrial operations, solid profiles are also sheared. The reason is the unmatched speed of the operation. In home and workshop conditions, it is common to shear sheets with manual or electric shears. Stationary machines include table shears or their interesting variant called rotary shears. They work just like a can opener with a cutting wheel. The cut may not be as clean, but it's sufficient for. This interesting multifunctional tool, which I got at uni-max, could also be included with the sheet metal shears. I admit I saw it for the first time in my life, but in the meantime, I spoke with the roofer Klemper, and he said he knows it and uses it. One of its functions is also cutting. Instead of straight blades, it uses a shaped blade that works similarly to a paper punch. The lower accuracy is compensated by great flexibility. The tool is powered by a drill and, in addition to cutting, can also saw like a jigsaw, and with the appropriate blade, of course. It can cut metals as well. If you have a metal lathe, you can cut bar stock by using a so-called parting tool. Anyone with a setup for autogenous welding can also use oxygen cutting, where the metal is melted and ideally vaporized, similar to laser cutting. You've seen for yourself that metal cutting is quite an extensive discipline. You need to choose the right tool based on your preferences. It depends on whether price, accuracy, efficiency, or perhaps flexibility is the deciding factor. That's also why I make these videos. For some, they are an inspiration. For others, an expansion of horizons, or simply a confirmation of their right choice. I'm already looking forward to the next adventure into the world of tools and workshop equipment.